So I'm going to be trying something a bit different today, which is to do sort of a scientific analysis of a story from EC Comics, A Trip to a Star. So I am very fascinated by the idea of interstellar travel. So this story is about just that. The first trip, this in this case, it's going to be two astronauts going to Alpha Centauri, and my analysis will be how accurate is this story and how feasible is it. So these two astronauts are loading into this very, very large rocket ship, and they are going to take the 4-year voyage to Alpha Centauri. So there they are, shows them in the rocket, blasting off. The story came out in 1959. And even though in this picture here in the upper right, it kind of shows them pretty far off of Earth, but then we get a picture of them feeling the effects of G forces as they accelerate away from the Earth. And so I assume it's using a regular rocketry to launch it, but then they are going to switch to atomic power turbines ready. And it says a switch is thrown, and again the spaceship jolted forward at still greater speed as the atomic engine took over. Rate of ascent 4,000 miles per hour. We'll hold this speed till we leave Earth's gravitational field, then we'll turn on the light energizing turbines. So already we have a problem, and that is that they're traveling at 4,000 miles per hour. In order to escape the Earth's gravity, you would need to be actually going over 25,000 miles per hour, which would generate a force of about 3 Gs, or 19.6 meters per second squared. The gravitational force on the Earth is approximately 9.8 meters per second squared. So they are not going nearly fast enough, but they kick on their light energizer and boost the ship up to the speed of light, 186,000 miles per second. That would not work for a couple of reasons. Number one, if an object goes to the speed of light, its mass would increase infinitely, which is impossible. Now you can get pretty close. I think what I read was about 99.99999% of the speed of light. The problem with that is that as mass increases, the energy required will also increase. And so I'm not sure, that is the theoretical limit. I'm not sure what the feasible limit is, but we have other problems that go along with that. So he says, well, Don, might as well take it easy. We got a long trip ahead of us. Yes, Jerry, 4 long years. So they're gonna experience 4 years to Alpha Centauri. So what are the problems we have here? Number one, they seem to go from, I guess, 4,000 miles per hour up to 186 miles per second, using their light energizing turbines. Now, the problem there is, so if you, the force of gravity on Earth is 1 G, which is 9.8 meters per second squared. If you took a plane, the gravitational force, the G force you experience on takeoff would be about 1.1 to 1.3 Gs. So although I wouldn't consider it uncomfortable, I would say the acceleration in a plane is not something you want to experience throughout the entire flight. So, for instance, if you were experiencing 3 Gs, which is about the force that you would experience on a rocket as it accelerates from the Earth, if your weight was 150 pounds, you would be pressing against your chair with about 450 pounds, triple. So if you weighed 150 pounds and you were accelerating in a plane at 1.1 Gs, the weight you would experience would be about 165 pounds. If you experience that throughout the course of, say, the flight, if it's a 2-3 hour flight, that would be very unpleasant, and to the point where I think people probably would choose not to fly. Um, in the amount of time it takes, if we go at a very comfortable rate of 1 g and accelerate at 1 g, it would take 0.97 years to get up to the speed of light. In other words, almost an entire year just to accelerate to that. And yet they're shown doing it, at least in here, pretty much instantly. You would be absolutely mashed to, I don't even know what material. You would be dead. Now, different franchises deal with this differently. In the case of Star Wars, it's kind of jump to light speed, and I don't think there's any explanation as to why the sudden acceleration doesn't just kill everything, flatten everything on the ship. In Star Wars or Star Trek, they use warp, which is faster than light travel, in which case they're manipulating space time. That is simply a plot convenience, and as far as I know, has no basis in scientific fact. So, my love of Star Trek is tremendous, but there's way more scientific issues with it. But the two big ones that I always think of is the fact that the Enterprise somehow has gravity. That seems to point. Now, in a ship like this, there would be simulated gravity with the acceleration towards the back of the ship. With 1 g, you would experience the gravity of Earth. With an instant jump to light speed, yeah, you got problems. Now, the other issue is that there is time dilation when it comes to moving at or near light speed, which means they would not be experiencing 4 years. They would be experiencing, if you were at light speed, it would take an infinite amount of time for 1 second to pass. So their time, the 4 years would be experienced on Earth. That's how long it would take. So if somebody did a round trip, theoretically, if it was a 4-year travel time, it would take 8 years to get there and back again from the standpoint of Earth. Whereas the people on the ship would appear to have not aged hardly at all. So the other thing is they're watching like Jupiter go past them and Saturn, and I don't think moving at the speed of light you would be able to. I'm not sure what you would experience. I mean, other than the fact that you would have a complete loss of time. But as the time slows down, the person on the ship wouldn't experience it. Now, they run into a problem where all of a sudden they have a loss of power on the ship, and then it goes black, and then they seem to black out for a moment, and then when they wake up, everything's okay, and they see a comet has gone past them, and they believe that has somehow restarted their engines, and Alpha Centauri is gone. Their destination has disappeared. So they do spot a star and make their way towards it, and it takes 6 months. Again, time dilation, you would not experience that time if you were moving at or near the speed of light. So they go to a planet. This is a star system, and by the way, Alpha Centauri is a triple star system, and it is the closest star system to Earth, about 4.3 light years away. So they seem to have kind of thrown caution to the wind and gone there just to see what's out there, which is, I would also add that I think that the mental strain of the trip would probably, if you were actually experiencing 4 years of travel, would probably be more than just about any human could handle. So they land on the planet, and there are some, let's say, strange creatures, and they are life forms with large heads, Hakpua, and they're taken to the city, which is a very advanced city. And when we came to, we couldn't find our solar system, so they're lost. They seem to have not only lost Alpha Centauri, but lost their own star system, and so the beings there take them to a planetarium and start to show them. Apparently, these creatures or these beings are very advanced, and they can pretty much show every star system at least in the galaxy. I doubt the universe would be there forever. Yeah, I think even the galaxy, they'd be there for an extreme amount of time. And they are absolutely not finding their own star system, which is Earth. And so this alien speculates that they went through a rift in time. And again, this is 1959, but this is a plot point that has been used over and over again in science fiction. Watch, I take this two-dimensional piece of paper, let it represent our three-dimensional world. I place my fingertip here. My fingertip represents your spaceship. As I lift it into the air, my fingertip enters a third dimension, just as your spaceship entered a fourth dimension. When I place it back on the paper, I place it in a different place. So did you return at a different place. So he's thinking that they have just jumped to a completely different place in the universe, some other galaxy, because they cannot find their own solar system. But suddenly they do. We sat down again in the darkened dome-shaped structure. Suddenly there was our solar system, the sun, the earth, the 9 planets in all its glory. Oh, I beg your pardon. That's it. That's our solar system. What? But it can't be. That is solar system 5320. This solar system, as it was over 1 million years ago, before the great meteor swept away the outer 6 satellites. But that's our solar system. Look, there's Saturn, the 9 planets. Gentlemen, I was wrong. You did not pass through a space warp. You remember when your heating system failed? Well, you were quick frozen for 1 million years. Then the passing meteor thawed. You are back on Earth 1 million years after you left. So that's the little bit of a twist ending to it. But basically, the point of it is no. Even in 1959, the science was very dubious. There are multiple reasons why this absolutely could not happen. But that is sort of my take on this story from 1959 and interstellar travel.